Clearly, we're not the only ones who are interested in generative design for horizontal infrastructure. You all are too, so thanks for joining us today. My name is Stacy Morican. I am currently with Gannett Fleming, representing the audience today in full force. Thanks for joining us. Gannett Fleming is a global infrastructure firm that provides planning, design, technology, and construction management services for a really diverse range of markets and disciplines. We're really heavy in the transportation sector with roads, highways, bridges, transit, and rail. All the boring credential stuff is up there. But while I was working at Gannett Fleming, I had the profound privilege of working with Mark Jaffe.
Thanks. Yeah, my name is Mark Jaffe. I have 3 years of experience in designing site civil, utilities, and rail projects. I really like creating Dynamo, Python kind of automations and just kind of thinking of ways to work better rather than harder. I currently work with PGH Long Engineering on the California High-Speed Rail project doing utility constructability review. Stacy?
Yeah, so let's go ahead and talk about our agenda for today, what we're going to get into. First, what we're going to be covering is why generative design, and really, what is it, right? It's not just a buzzword, there is meaning behind it, so we'll get into what is generative design. We'll also talk about how you, too, can get started using it inside of Civil 3D. Then we'll get into a proof of concept, where we'll walk through how we got started and the case study that we went through, and how we used it. You've all seen the key learning objectives. That's why you're here with us today. What we will not be covering today is a technical demonstration. If you're expecting to come in here, this is a case study, so if you were expecting to come in here and get some technical know-how, we're going to show you the sausage. We're not going to really show you how it was made. Sorry. So this is a case study to walk you through what we have learned thus far on our journey with generative design. Few housekeeping items. Please be courteous with your mobile devices. We are streaming live for all the audience out there. And we have some time at the very end for questions and answers, okay? All right, so why generative design? Well, if you think about your typical engineering design process with every single project that you do, we know that in the beginning, we research the problem. Right? We understand those design criteria and the requirements. We brainstorm on possible solutions. Then, Then we move into the design or optioneering phase. This is really where we start to create sketch plans. We iterate, we test, we evaluate, and we come up with what we think is a good design option. We present that to our client, and then we go back and we reevaluate, we retest, and then finally, we produce sheets or we deliver that project through sheet productions or some advanced design process. But if you think about this entire site design process, the most time that we spent and the biggest pain point here is really that whole iterative process, right? We're sitting there, we're creating sketch plans, and then we're retesting and reevaluating. And most of the time, what our final design wasn't anywhere close to where we were in the very beginning. This costs a lot of time. How many of you, really quickly, show of hands, know anything about rail yards or are in the transit and rail industry? I can't see your hand. Up. Okay, a little bit of you, right? But for the majority of you, that's really what our case study is about today. It's about a transit and rail yard that we went to design and complete. Now, we can't show you the real design yard or the real rail yard, but this video here to the right-hand side gives you an idea of all the complexities that are involved in creating a rail yard. There's lots of constraints, lots of complex areas. For our project in particular, we had a 72 rail car storage area and 5 facilities. As you can see from this video, rail yards are typically hundreds of acres. For our case study, we had 20 acres to deal with. Yeah, really constrained. Just to give you an idea, the design attempts that we tried, again, just conceptual, that whole process of sketch plan, we did over 50 design attempts, which took us over 600 hours, I think. And in the end, what we provided our clients was 3 feasible options. Just some quick math here. If we bill out at $150 an hour times 600 hours, that's $90,000 on just conceptual design. That doesn't account for the reiteration or the production or delivery of that. That's a lot of money. So then we started talking about there has to be a better way for us to reduce this amount of money, reduce this amount of time, and reduce this massive pain point in our design process. And that's where we started talking about generative design. So generative design is not just a buzzword. There is methodology and processes. But to understand that, I want to take you back a little bit. Maybe over the last 5 to 10 years, I would say, there's been a massive progression in technology. We first started out with CAD, 2D CAD. Everyone in this room knows what 2D CAD is, so I won't go into grave detail. But then we moved into parametric design, where we've got things like Civil 3D, and we can start connecting data with the geometry that's inside of our drawings. Over the past, since 2019, circa 2019, is when we were given the opportunity to use Dynamo inside of Civil 3D. So that was only 4 years ago. And that is our computational design, AKA Dynamo. Now we can start using Dynamo to automate some of those repetitive tasks. Today, what we have is generative design, which really takes the parametric design and the computational design and marries them together to create generative design. Maybe a little bit better way of explaining it is this technology stack, where you've got Revit or Civil 3D at the very bottom. On top of that is Dynamo, and together we can create generative design and use those APIs to create that. Okay, so, we get it. We understand in our conversations that we need to come up with a process. We understand that generative design is out there. We've heard a lot about it with Revit, but could we really do this with Civil 3D? How do we even get started? Well, I can tell you that fortunately the answer is yes, we can get started, and through our advisory services with Autodesk, we were informed that we could take the generative design folders out of Revit, so this still works with Revit 2023, the whole way back. I think when we did this originally, it was 2021, was the version that we did it, but it still works with 2023. You have to have it installed, and then what you do is you take those folders and you push it into the Civil 3D folders for Dynamo. This is a hack. You have to do it this way because generative design is not part of the installation today. So Autodesk Dynamo product team, if you guys are out there and listening to us, I think we met him yesterday in one of our classes. Hint, hint, wink, wink, please add this in here so we don't have to do this hack in the future. Once we copy those folders over inside of Dynamo, how many of you are using Dynamo? Oh, yes, that's a lot. Great. Awesome. So as soon as you copy those folders over, inside of Dynamo at the very top of the menu, you'll get this generative design menu, all new. Underneath that generative design menu, you'll get some options to take a look at what's new in generative design, but most importantly, the create study. A couple of add-ons that you get or nodes that you get in the add-on list, so all of the Dynamo people in the room will understand what I'm talking about with nodes, but you get 2 specific nodes here. One is the data remember, which tells the generative design tool what parts of our design to iterate. What parts are we having to go back in and keep doing repetitively? The second is the data gate. This allows that iteration. Again, this is for my Dynamo folks. It's a little bit more technical, but this allows that iteration process to happen without it actually changing your design inside of AutoCAD. So it just creates a gate for it and then allows you to choose what portion of that iteration you want to then push to AutoCAD or Civil 3D. And there's just a quick glance of what those 2 nodes look like. So, okay, now what? We've got all of our business processes done. We understand that we need to do this. We got all of our folders moved over, so we have the create study. We've got our nodes. Now what? Now this gets into the proof of concept, a little bit more technical, and this is where I'm going to pass it off to the technical guy on the stage.
Okay, thanks, Stacy. So we really want to figure out, if we know that generative design is possible, how do we implement generative design in real life? Where do we begin? So we started by kind of thinking about analyzing our current design process. What you can see here on the right of the screen is sort of like a tree flow diagram. And these little green boxes indicate at the very top where we originate our design information. There may be design criteria or some kind of standards, all the way to the bottom, which is things like planned production or actual deliverables. Once we understood our process and how we design rail yard layouts, we used a sort of what's called a swim lane diagram. And we broke it up by roles and responsibilities. So each of those little bars you see is a role and responsibility. We identified that iteration and I believe it's refinement is really where we think generative design could help us along in the process. And specifically, we identified 2 activities that we do that would be great for automation that are mundane, take a whole lot of time, and just might be a waste of resources. That was moving facilities and connecting tracks. And keep those 2 in your mind because we're going to keep revisiting them later on in the presentation. Moving facilities around consists of engineers moving buildings around to make sure that everything can kind of live on a site and serve its intended purpose. Connect the tracks is something that a track engineer might do because the rail yard rolling stock needs to go in and out of shops. Maybe needs to go in and out for service. So you need to connect the facilities together where the tracks will be designed. Now, this business process analysis enables team communication. We identified our pain points, and we also determined which steps were appropriate for automation. And this is just one graphical business process analysis approach. There are others, such as a gap analysis or value-added analysis, that might be more appropriate for your specific case. So, but why? Why create these fancy diagrams? Can I hear from the audience? Why create fancy diagrams? Say it with me. Why create fancy diagrams? I like it. There are some people here that are going to be like, oh, you know, we don't need those. Well, let me convince you. So we had 3 main benefits that we identified. First is we identified specific tasks for automation. That's gold. Secondly, we understand the flow of information. If some of you have worked with Dynamo before, maybe you've done some coding, it's all about the data. And when we start to sort of begin to program things, we need to understand where all this data is coming from, if it's in a form that can be readily available for computational purposes. That's really important, even at this stage of the process. And lastly, we knew that this is our first venture into generative design. And we didn't want to take on more than we can chew. We really wanted to sort of ground ourselves in these simple automations and maybe take bigger challenges later. So we identified the low-hanging fruit. So with our business process analysis completed, we decided to take our first leap into generative design. Now, when thinking about those 2 tasks that we had identified, moving facilities and connecting tracks, like I said, we want to identify the low-hanging fruit. And the Dynamo community and the Autodesk community, as vast as it is, has already sort of solved certain parts of that problem. We already know how to use Dynamo to move blocks or lines around on a site, right? So I think that our first problem that we should solve is one that's going to be easy, and that is moving facilities. So maybe about 1 or 2 years later, here is the finished script, just like that. It's done. Presto. So we said in the beginning that we're not going to show you the technical side, but I do want to show you how a generative design script is organized, because it is fundamentally different than just a regular Dynamo script. So we're going to go through the different pieces. of the puzzle, and we'll talk a little bit more about some ones in depth. First is the variables. The variables might be your AutoCAD geometry that you select, or it might be numbers, or it might be strings. Anything that the tool needs to actually understand what you want to do. We're pretty familiar with that. Our next group is the generator. So if anyone here has worked with generative design in Revit, generative design works with design script objects. For layman's terms, it works with things that are created inside of Dynamo. So we need to include a section of code that's going to take something like a polyline and put it into a Dynamo instance. That's what this generator is doing. It's like a translator almost. Next, we have the nodes that Stacy was talking about. We have remember and data gate out. Remember tells the generative design tool what to actually modify. And our data gate out, it's basically a toggle switch that when we have found a generative design solution that we like, setting that to true will actually push that solution to AutoCAD and modify our file. So everything is done in Dynamo, and only when we say data gate out equals true do we actually push that out into AutoCAD. So, that's nice. Next are the input and actions. These are parameterized actions that might be moving a site, maybe a number of degrees for rotation. These are basically going to move facilities around on a site just as an engineer would. We're just giving that control to a computer. We have a visualization block because in the generative design user interface, which you will see in a couple slides here, we want to see how things change and how they're modified in the tool. So we'll have to include that as well. Our last section is evaluators. Evaluators are metrics. They measure the success of our design. And we're going to talk about those in depth right now. So evaluators are floats or integer values that measure the success of the design. As engineers, one of the challenges is that the best design is not just something that can be measured, right? It's a balance of pros and cons. I don't think anyone has ever made a final decision solution that has everything we want, right? It's a balance. But the challenge is that the computer doesn't understand that. It only understands math and logic. So if we're going to measure the success of a design, we need to do our best to try to translate that holistic process into something that the computer can understand. In this table, I've included just a couple examples, and they're kind of the easy examples. My apologies, evaluators are hard. But say, for example, if we want all the buildings to fit on the site, for example, we can't really build outside of our right-of-way. One way that we can translate that into math and logic is to have Dynamo count the number of intersections with a site boundary polyline. And if they are 0, we can assume that the building is contained within the site. Right? Yes? Yes? I see nods. Okay, great. There's some other Rails-specific ones that might be a little bit more niche, but yeah, that's what evaluators are. So once we've built the script, we now have to actually create the study. And that is accessible through the generative design dropdown in Dynamo under Create Study. Now, we're going to go over the different study types. You're going to see a term that says 3-box massing. This is just an example that's built into Dynamo. Don't think about it too much. We just want to show you what it looks like. So the different possibilities are optimize, cross-product, randomize, and like this. So these are your different possibilities of ways that you can solve for generative design solutions. And we decided to use randomize because we were interested in all the possible outcomes for a generative design study. Now, if you'd like to learn more about the others, you can see our handout, or you can go to the generative design primer that Autodesk has put together for Revit, sadly. Maybe Civil 3D is coming, I hope. But it's still very good information. So once we run our study, we get something that looks like this. What you can see in the small boxes are the actual design possibilities. On the right side, you can see our design, our outputs, and inputs. And here, we're dragging over a range of inputs and outputs to filter our results. Pretty cool, right? So our evaluators are those inputs. We can filter possibilities out by what solutions are desirable. Of course, we want 0 intersections for the site boundary, so we can select that. And we can see the inputs too, so we can see where things are being positioned. Now, if we look at the different design possibilities, there's something that's a little bit weird, right? If each of these little polygons is part of the site, some of them are outside of the site boundary. That's not really a solution, right? We're saying, let's build this outside of our site boundary. So we kind of saw from this exercise that we need further refinement. We also kind of saw that a lot of the solutions kind of look the same. And we want unique solutions that are going to contribute to our overall engineering process. So let's talk a little bit about refinement. So to say it lightly, the first working script was a great first example, but it was kind of a fluke. And we had to add a little bit more refinement into it. And I'll go through exactly what you see on the right here in a minute. So we decided to do 2 things. We recognized 2 challenges. One was translation and one was rotation. Translation, originally the generative design tool could choose any translation, 1 foot, 0.00001 foot. They were all unique possibilities, right? But what we wanted was something that was more unique. So we created a grid of points that are regularly spaced out across the site, and we told the generative design tool to choose one of those points instead of choosing a random translation. Same for rotation. Instead of rotating 1 degree or 0.1 of a degree, rotate using a sequence of numbers. A sequence is something like 0, 15, 30, 45, and so on. What we ended up kind of having is more unique design outcomes that were more feasible. But at the same time, you're taking some control away from the generative design tool. Whenever you use a computational design approach, you need to be careful. Because if we impose too many constraints onto the generative design tool, we're going to limit our outcomes, right? So just a word of caution, when you are refining, be careful not to pigeonhole the design into one solution. So now that we've completed the moving facilities portion, we need to kind of reflect on our original purpose, which is to kind of apply this to rail. We can put buildings on the site however we want, but if we can't connect the tracks together, it's of no use to us. So problem 2 needed to be solved. We had some background in generative design and had to continue. So connecting the tracks consisted of designing a computational approach to actually connecting 2 lines together in track geometry that makes sense. And if you're not a track engineer, don't worry, we'll make it easy for you. So the first question we need to ask is, how does a computer know where to connect the tracks? If I want to go from building A to building B, how do I communicate that to Dynamo? And we thought of 2 possible ways. One way was called using a connectivity matrix. Who here likes Excel spreadsheets? Yes? Okay, it's like half the room. Okay. So one of the benefits of the connectivity matrix is that it's familiar. An Excel spreadsheet is easy for anyone to use. The intersection of a row and a column and an X there tells Dynamo where to connect. But it also kind of gets a little bit complex when you have a really complicated site. And we want to kind of get away from our Excel-centric processes. We already have enough spreadsheets. We don't want more. So another approach we came up with was flow rules. Flow rules uses a custom Python script, combination of text parsing and regular expressions, if you guys are familiar with it, But basically, we give it a sentence of text, and it can understand the origin and destination from that sentence. So if I say car wash to cleaning platform, it knows car wash is my origin, cleaning platform is my destination. Now, some benefits is that this is a really straightforward interpretation of our design criteria. We basically have to do very little work. And we decided to use flow rules because it was something different, it was something innovative, and it allowed more flexibility further on. Now we had to define the facilities, and it's pretty straightforward. Many of you might be familiar with attribute definitions or property sets. There are a slew of ways that you can embed more information in Civil 3D objects that will help Dynamo understand what you want to do. So for Rail Centerline, we used a layer. I'm not going to go into great depth on this, but if you guys have questions after, you can ask the question. This is nothing new. Next is to actually solve for the connections. How does a computer know how to connect the tracks? So connect the tracks connects the tracks 5 different ways. 1, 2, 3, 4, and 5. It's pretty much just like a basic positional vector problem. All those math nerds might know what I'm talking about. But when we want to find the most feasible connection, we look at all these 5 possible connections and we choose the shortest chord. And for our example here, that's number 4. When we have the shortest chord, we identify the tangents and connect them together, which here suggests a connection point between start point of 1 and start point of 2, and we get that curve. Okay? So, great, we have a computational approach to connecting tracks. But as you can imagine, solving one connection 5 different ways takes a whole lot of computational power. And in our trials, we saw that it took about 10 to 15 seconds for the change to actually be implemented. Now, that might be okay for a design implementation where you're doing this a couple times. But generative design might be doing this hundreds of times. So we don't quite think that this program is ready for implementation in generative design, but we do think that it's still a valuable tool that could benefit engineers now. And that's why we decided to incorporate connecting tracks into a design aid. What you can see here, shown on the screen, is a video of us running Connect the Tracks. Connect the Tracks is on an automatic basis in Dynamo. When we move a facility, Dynamo understands how the track should be connected, and it refreshes those connections. It can be one facility that is translated and moved. It can be rotated. You can move the entire site if you like. Dynamo has a lock on it and will do everything to preserve that lock. So, what did we learn from connecting the tracks? Well, it also had some implications that, while we're still developing it, could help us in the future. For one, it started conversations on user interface. If you ever made automations before, you need to make them easy to use, or it's likely that they will not be adopted. We also learned a lot about file prep. There's a lot of things that need to be set in stone before the tool can use them. You can't make an automation for everything. We also wanted to make sure that it was easy to use and easy to implement on other projects. If we think about how we can make things better now, it increases our chance that there's less work in the future to widespread adoption for this technology in our business. So, if we bring these 2 problems together, moving facilities and connecting the tracks together, where are we headed? So, our end goal is that we believe generative design can be leveraged to show all the possibilities for facilities on a site and shows how they will be connected. We think that this is best for conceptual design because it's such a time-intensive process. But anything past conceptual design into the 5% phase it just gets so specific and so hard to program that maybe it's better left to the engineer. But what we can do is show some of the engineers some of the possibilities without having them to spend hours to figure it out. We also envisioned a company-wide modular approach to generative design. We could use Dynamo's node framework and node sharing to basically make moving facilities and connecting the tracks custom nodes. What if other business lines could create their own nodes that tie into a generative design tool? I saw that we had a lot of people that are not in the rail industry. You could have water, you could have land use, you could have all these other industries and parts of our business contributing towards an overall generative design solution. So for the next slide, I'm going to pass it over to Stacy to wrap it up.
Yeah, so let's wrap up by tying together what we learned through our generative design process with some of the business values that we've realized were brought to Gannett Fleming during this process. So some of those business values certainly include an increase in profitability because we're able to control some of those design costs, right? By applying different iterations, we're able to drastically reduce that 600 hours that I talked about in the beginning and $90,000, I think it was. So we were able to reduce or control some of those costs through increased profitability. We were also able to improve our design quality. We were able to maybe weed out a lot of those fluke instances and get closer to the final design a little bit more in the beginning of our project. And of course, that's going to improve our client satisfaction. What client does not want all of these iterations in less time and less costs? So some of the operational efficiencies that we gained was a reduction in overall design time. I think that's pretty apparent. Less time, certainly reduced through increased hours spent on repetitive tasks. We are not repeating it and reiterating it. And our total time to design completion drastically shortened. So we're not spending 600 hours, maybe we're spending 60, maybe 300. And last but not least, some of those risks were that we met or exceeded the design requirements. We're not relying on designers or doctors or engineers to make sure that they're making the right radii. We're ensuring that those design criteria are met with every single movement of that design aid of connecting those tracks, which is reducing errors and a bunch of rework for us. So we hope that you learned that by combining computational design and the optimization process, that your teams could benefit from this tool as well. So some additional information, we do have a handout that goes into a little bit more detail. As Mark mentioned, there's also a generative design primer, which is essentially the help document. Take another look at that. It will certainly help you along the way. Special thanks to 3 people, and particularly Matthews Mathai is our consulting services with Autodesk, who helped us realize some of these ideas, brought in Seth Edwards from Autodesk, who's really technical and understands generative design really well. And last but not least, Michelle Rasmussen, who is not only the content strategist, but was our mentor during this process and helped us bring this story to you today. I think at this time we're ready to open it up for questions. If you guys have any questions, or if we have any questions from our audience online. No questions? We were that good at what we did? I think what they're going to ask is that you line up over at the mic just so that way we can hear you, because I don't think we have a mic to pass around. Is that the case? Yeah. Yes. If you have a question, go ahead and line up by that mic back there in the corner. The moderator, we'd be more than happy to answer it.
All right, I have our first question from the online audience. They asked, is the generative design graph scalable with other projects of the same type, or are you making a new Dynamo graph for each project?
Yeah, I guess that's an important point to note, right? Like, we used this as a case study for rail yards, but this could be applied to many other practices. If you're moving facilities or buildings, or you need to connect alignments or pipe networks or anything like that that's horizontal, this same idea could be applied to multiple facets. We just used it for rail design because Mark's a rail engineer, so But yeah, you can use it. I think the input values are probably what you would want to change based on your own design needs and requirements.
Did you consider the overall site grading design in any of this?
Yeah, so what we're talking about here is just generative design for horizontal, right? And that movement. And once it gets into place, then we can start talking about optimizing and using some other tools like grading optimization that are part of Civil 3D to help optimize the cut fill of that site. This was really just focused on horizontal. Mike?
I would add to that and say, even though the generative design tool is presenting possible solutions, it still takes a skilled engineer, such as yourself, to look at the different possibilities and see how much room there is for interpretation. You could maybe build some kind of grading minimization optimizer tool into it if you have access to that data and it's accurate. But for our conceptual design phase on the rail yard layout, we didn't yet worry about that.
Any other questions?
All right, we have another question from the online audience. They asked, how did you pitch the idea to test generative design to the management level, and how did they receive it?
Yeah, that's a great question. I like that. This kind of goes into our whole like innovation philosophy, or at least with me and my supervisor at the time. We wanted to first do the business process analysis, identify the need, and then we communicated that need upward to management. We made little incremental steps, like a proof of concept, or maybe just trying to move one facility. So we kind of kept the time investment low, but still we're thinking kind of big picture. It's only when we started really getting into, creating the custom scripts that we really had to get management's, approval to keep spending time on this. But you can still make a lot of progress, kind of under the radar, if you will.
And it helps that, Gannett Fleming is really dedicated to innovation. So they gave us the time and the time really to work on it and really bought into the idea. So it certainly helps. Any other questions? I thought I saw one in the back there.
Yes, thank you for the presentation. This was phenomenal. First part of the question is, at how many use cases will the generative design or the cost of the generative design exceed the cost of the conceptual design using traditional methods? And then I have a second part, which is what multiplier should we use when planning this from the forecasted amount of hours to the point that you got to today? So actuals over planned.
I think those are good questions.
Yeah, I'm not sure that I heard all of it, to be honest with you. I heard like little bits and pieces.
Yeah.
One was I hate like you gave us a lot of questions in one.
But, the feasibility of it, that's kind of what it was along. Stacey, you want to...
What was the question specifically? Did you hear it? I did not.
Sort of quantifying or if you want to go again.
Yeah.
Yeah, apologize. Thank you. So the question was, if you consider the cost of developing the generative tool versus the cost of doing the same design in a traditional methodology, how many iterations would it become cost positive?
Yeah, so I think if I'm understanding what you're asking is like, how much time do we spend on this tool versus just spending it on reiterating it, right? Yeah, that's a good quantifiable question, but the next project that we work on or another practice in our organization that wants to utilize this can then use it. So I think exponentially we'll see those benefits. I'm with you. It took some time, right? It took a lot of brain power and manpower to put this together, to understand what the process is. But moving forward, I think it's going to help us and benefit us in the future. Just like, when we first started going from hand drafting to 2D CAD, nobody really saw those benefits, but look where we are today. So I think exponentially, we'll certainly see those benefits with other projects.
And in terms of quantifying its impact on your organization, that is really what the business process analysis will highlight, and it varies so much from organization to organization. Our pain points may not be the same as your pain points. So it's really hard to kind of quantify a financial impact number. But I agree with what Stacy said. If we had this, we probably would be better off in the future.
And it's really important for us that our clients are satisfied with what we're giving them. And if we're spending $600 and we're providing them with, 40 different design options versus 3, I would hope that makes them pretty happy. Was there a follow-up question to that too?
Yes. So the question was, as you encounter problems that were not predictable when you started the project, that assumedly it would take longer to develop the generative design than was originally planned. So I'm asking, is it orders of magnitude, more time, or is it a multiplier? I guess, can you share any insights into what we should plan for when we're developing these tools ourselves?
So that's a great question. I can think of one modification that had to be made later on in the process, and that is they wanted the minimum radius to be increased because they were having issues with their maintenance of way equipment. So if you use a typical design approach, now some of the options that we had looked at wouldn't have worked because now the curves are getting longer, the site's getting bigger. But if you design your script properly, that's just a variable. Instead of maybe 50, you say 60 feet. And so the change in rerunning that tool, you can have your results in a couple of minutes versus hours and hours of effort to redo those concepts that were feasible.
And to add to that, you noticed in one portion when we were trying to connect the tracks, we failed. Right? Adding the buildings and connecting the tracks is just taking too long for the generative design process to happen. So when you make a really good point. At that point, it becomes like it's easier for us to just use it as a design aid. So we still got some benefit. We still receive some benefit from going through this process because now our designers and engineers can go in there and move a building around and connect tracks. So we still saw some benefit, even though we didn't maybe merge the two together just yet. Did we answer your question? Thank you. Sure. Any other questions?
Yes, there's a couple more from our online audience. What is the learning curve for Dynamo? Did you find it easy or hard to learn with controlling AutoCAD?
Generative design or Dynamo? Because generative design, that's Mark. Dynamo I found pretty easy to learn. But generative design, I think it's a little bit more.
I would definitely say that generative design was sort of started in Revit. So there is still some support networks out there that can help you get started. But I think in terms of implementing it into Civil 3D, it is a little bit more difficult. Connecting the tracks is a very complicated problem for Dynamo to solve. And I think the script is like 300 to 350 lines of code. That's definitely a very advanced capability that you can do those things with Dynamo Python. But I guess my answer would be you can get core functionality with a pretty low learning curve. But if you want to do those really crazy, insane kind of things, it requires a lot more time investment, a lot more knowledge. But those support networks are out there to help you.
For sure. Any other questions?
Dynamo doesn't do well with large coordinates far from 0. How do you overcome this issue?
Could you say it again?
Someone wrote, Dynamo doesn't do well with large coordinates far from 0. How do you overcome this issue?
Dynamo doesn't do well with large coordinates.
I don't know that I've ever encountered that. I know that there's a setting, if that's maybe what they mean. I'm not quite sure how to answer that, but if they're getting a warning symbol inside of Dynamo, I would recommend checking out the settings and accounting for, I think there's like a small, medium, large, and extra large for those coordinate systems. Yeah. So check your settings in Dynamo.
And all of this stuff that we were doing for the computational design, it was in the right coordinate system, in the right point origin. So I'm not quite sure.
Any other questions?
Was generative design drastically different than what an engineering would have come up with and saved on the project?
That's a great question. I kind of played with that a little bit when I was like starting to kind of see, kind of making like a verification set, if you will. I put so we had 5 buildings on the site, right?
Mm-hmm.
I put 3 of them in their locations where the engineer assessed that they should go for the final design, and it seemed like it was converging towards the right solution. So it's still very much a work in progress.
Yeah, and I think it's important to note that what we showed you here was just like a small portion. We could put in any number of iterations. I think if we went back to the slide deck, you would see like 40 of 40 iterations that we've shown. Just because that's the number that you can enter into generative design yourself. So, I mean, it's really up to you how many design options, and like Mark said, it was a fluke, so then you add more constraints, and then you start to really weed out the stuff that's not going to work.
Yeah. Mm-hmm.
Any other questions?
That's all the questions we have online.
All right, then we did a really good job.
If I would just comment, one more thing is
Okay.
On that previous question, is a lot of this stuff is not generative design. We're talking about good Dynamo script design. So there you might have a low fidelity of good outcomes, but it might not be the generative design tool that's not realizing those. It's a balance between refinement and creating those iterations.
Sure. If there's no other questions, thank you all for joining us. Really appreciate your time. Have a great day.